like to talk about macro models for proof of stake blockchains, and I guess Ye already sort of gave some motivation. So I'm not gonna talk not gonna spend any time on that. I'm gonna get right into what I'd like to do. What I'd like to do is talk to you, give you two examples of models. One is a very basic, simple model. It's just gonna connect a few sort of key quantities of in a proof of stake blockchain, and then the second is building on that. It's extending it to the Ethereum macroeconomy, and I'll talk about Ethereum monetary policy from within that framework. Okay. So that's the plan. So a basic, sort of. My view of what sort of the most basic proof of stake model in this style is one that connects these quantities. You see, so it's connecting the money supply, which is split in two uses. It can be used by by end users. They do transactions. They use it as collateral, and the second use is can be staked. Yeah, so it's the D for deposits. That's the staking, and the MU is money used. There's a price. The price is in that's a dollar price of a token, and there's the staking yield Y. That's compensating stakers, and so the Y. Think of this as that's the policy variable. Okay, that's sort of the protocol designer decides that, and so that's the model. And in this model, you think about a blockchain. It's like it's a small open economy. Okay, so it's an economy that's affected by it's affected by the rest of the world or the outside other blockchains, but it's small enough not to have not impacting anybody outside. Okay, so these are the elements, and it's sort of a standard macro type setup. Okay, so it's a representative agent framework where agents they solve this problem. They maximize their lifetime utility subject to budget constraint. The key in the what they optimize, it's this money and utility. Okay, so that's sort of a reduced form for the utility value from the money. That's the token. So it's the transaction, as I said, is paying fees. Doing other things with your token, and that's what enters. It's the dollar value, if you want. Okay, it's the real value, the real balance. It's not just the amount of tokens. And then this is the budget constraint. So every period that the agents they choose how much to stake, the D, and how much to use. They start the period with some stake and money used from the period before. They get the compensation, and they make the choice for next period. And so that's the most sort of simple framework. I think I can come up with to capture these quantities, and then there's a money supply equation. Okay, so that's something that holds at the aggregate level. Money only is only issued here in this simple case through seniorage to reward validators. Okay, so then you solve this. So an equilibrium in this setup is these agents take prices as given, they take the policies as given, and then they just optimize. Okay, and then the equilibrium, you can summarize it as these three equations. So these are the two first order conditions. These are pricing equation, if you want. It links the price to the expected future price. This is the discounting with the yield. Okay, if you're if the money is used for staking, you get the staking yield. If it's used as sort of a final end user, it has this the money utility is the marginal utility for money. Okay. This equation shows the sort of the dilution effect when you finance staking rewards through money issuance. Okay. So staking rewards, if you think that if that gets increased, so a higher staking reward gets promised, this captures the required return, and so if this goes up, then the price is expected to grow less, and it transmits to the other equation. Okay? And so if this yield goes up, this marginal utility goes up too, and the way that goes up is in equilibrium. There's going to be less money. Okay, so that's the if you dilute, if you issue money to pay stakers, you're not just diluting. It's not just a transfer, but it's a distortion. The users will take that in account in advance, and they will use less. And so this is of course a very standard mechanism. Okay, this is just a classical monetary mechanism of inflation as a tax. Okay? Inflation is a distortionary tax. You had a question?
Well, so I just wanted to sort of ask you to maybe provide a little bit of context on like the parts of your model where Ethereum kind of comes in. The sense like a lot of what you're talking about can be thought of in sort of a more general macro finance structure. Yeah. And particularly when there's like a lot of math on the slides, I feel like if you can provide a little bit of like the pieces we should be looking for specifically where kind of Ethereum really comes out separate from kind of the traditional macro finance.
Yeah, well, I guess this was supposed to be the baby model introduction. The Ethereum is going to come in a moment. Okay, so this I guess this is sort of generic proof of stake. Okay, and I guess I showed the equation just so that you know what it is. I mean, this is not. Yeah, I mean maybe. Okay, so, but we'll get to we'll see it in detail actually. I think what we've seen this morning, we'll try to connect it to a bunch of these elements. Fine. All right. Okay. So this model, if you make it a bit simpler, just deterministically, this is just these three equations, and so this is a standard sort of dynamic system. We can easily solving on a computer. Now it turns out you don't need a computer. And even with you don't even need to specify utility function. You can just solve it like this. Okay, so when so that's the solution of this model. So you start from any monetary distribution holdings, any initial staking reward, and then in the first period and from there on, if the yield is constant, okay, that's the deterministic setup. That's the staking share. Okay, the ratio that's staked. It's just pinned down by this discount rate. That's the required return and the staking yield. And so what does this say? It shows you that the more yield is promised, the staking share. Okay, the ratio is going to be higher in equilibrium. In this solution, the staking share is a constant. Okay, it's a steady state, but in the model, money is growing. Okay, the two usage are growing at the same rate, and the price is declining at the inverse. Yeah? So think of this as sort of a steady state, a steady state in this setup where the growth rate is constant, but quantities are growing and they can grow at different rates. So what is this? If you look at it, it's basically it's not a demo. It's a supply. Okay, it's the supply that's supplied to the network as a function of the compensation. Okay? So one thing, of course, you can do is just look at plot it out and compare it to some of the blockchains we see in the cross section. Okay, so that's what we have here. So it's the supply, so it's the yield that's implied by the staking share. So it's sort of the inverted function. And the blue line is the model. Okay, it's just that's what you get. There's only one parameter. Okay, it's just that required return, and here it was sort of fit to, it's selected to get the best fit. Okay, and these are the 20 largest proof of stake blockchains, and I guess you'll see them. Okay, so now does it fit actually? So the fit is actually not very good. Okay, if you just do a
question.
Yeah.
It's a graph and you calibrated the model, and then you are showing the results of the calibrated model.
Pardon me?
And you calibrated the model.
Yeah, this is the calibrated model. There's only one parameter. Okay, I just pick this parameter. Okay, that parameter it's basically it's the required rate of return, and here it's about 3%. As annual, and then that you get the line. There's nothing else. Okay? The calibration is very simple. Okay? That's as I said, that if you want a formal fit, the R square is barely better than the mean. Okay, even though I guess it can look pretty good. It looks better if you erase two outliers. Okay, if you erase the two outliers, you get a really high. Then you get an R square of 0.5. So that's one way to feel better about it. Another way is just to look at where some of these blockchains are, and you can see that some of the more the larger ones and those for which we this is a deterministic model, so it's more likely to capture some sort of stationary distribution or steady state. So those are the ones that have been around for longer, and they're pretty much on the line. Okay, yeah.
I'm just curious, like are these just the staking rewards, or is this like the net yield, inclusive of MEV and all the other stuff?
It's just downloading it. So I didn't spend that much time, and I'll see in a moment why. Okay, so this is just the first cut because of the model is so simple. Okay, all these elements are not in the model, so then if you add them, then you have to decide what to go. This is just sort of a first cut, big picture. Now, what does it say? Okay, if you want to summarize what this says, of course you've seen the equations, but we sort of go backwards. It just says, there is a required rate of return that has two sources: the yield, the staking yield, and the price appreciation. And in this model, because it's so simple, the price change is just the inverse of money growth. That's the dilution, if you want, and that we can, the money growth equation just links it to the staking yield. Okay, that's it. So it's in words. What this says, it just says that there's a required rate of return, and in dilution, once you dilution adjust the staking yields, they should be roughly the same, and that's what the blue line is. They all have the same along the blue line. It's the same return. Look at once you dilution adjust the staking payment. Okay, so. So what's, as you said, what's missing here? Of course, this is very basic. So there's a lot of things that are missing. So not too surprised, this is not fitting perfectly. Okay, obviously. So there's no risk. There's no risk premium. There's no growth. Differences in growth. There's no fee income. No MEV. Okay. And so the model I'll show you next. So that's the Ethereum model. When I put these things are going to be in there. Yeah? Okay, let me start on Ethereum with just a few trends, sort of macro trends on Ethereum, and then sort of discuss some of this from within the model. So this is Ethereum switch to proof of stake, a bit more than 2 years ago. Staking. This is the staking share again. So this is just the ratio of staking over the entire money supply. It's been increasing, and when it's sort of the line here, it's basically running at capacity. Okay, there's a maximum amount that can be added per period. Of course, that's good news. It's going up. Okay, the good news is that this means it strengthens the economic security of this blockchain. This right now that's about $100 billion worth of security. From the stake. The not so good thing is that it's expensive. Okay, that it is paid, as we've seen. It's paid through the stakers are compensated from resources that are taken from somewhere. It's also another concern from what a number of people think. They're worried that this is going to increase more. Even though the last few months it doesn't look like it, but they're worried that this is going to increase more, and then it will have sort of additional negative effects on top of just the costs. Okay, it would lead to, it would sort of affect the protocol. And so there's been a number of sort of research posts from Ethereum Foundation discussing ways of changing the issuance. So as to make sure this doesn't go up a lot more. Yeah, so that's I think it's a project that's alive, and it might come in one of the next updates. But of course, given that it's pretty fundamental, very take a while until any sort of agreement on how that would look. And so that's of course one of the key questions that I think with these type of models we could sort of look into it. L2 activities, of course, we've seen this morning extensively, so that's some sense good news. The numbers, you've heard them, L2, the transaction per seconds, that's been increasing, and so that's this roll-up centric growth or scaling is working. It's working well. Ethereum is known to be able to generate high fee income over extended periods. So this is in millions of dollars. The line here is 500 million. The colored parts are the L2 fees, and the gray one is Ethereum. So one thing I think it's pretty clear this is on a downward trend, and in the recent months it's been very low. Okay, so now some of that, of course, that's due to deliberate policy choices from Ethereum, and in many ways this could be viewed as good news because now it's easier to build. And if you build something, you have lower fees. On the other hand, of course, people that look at fee income as a metric for value, that's not so good. And so this is another line usually. This is the price of Ethereum in Bitcoin since going proof of stake. Moves from about 0.08 to 0.25. So it's down to about 30%. Okay, so now this is with respect to Bitcoin. Of course, maybe it's Bitcoin that's driving this, but it's if you look at other like Solana, it's also on a similar downward trend. It's a bit of a question of why is it going down if the scaling and everything seems to be working so well. Okay, so this is, I guess, it's a bit of a puzzle. So these are some macro trends, and now the model that you've seen before, I want to augment it. I want to add a bunch of features that are Ethereum specific. So I want to include the fees, gas, and the L2 sector. So I guess most people know how this works. Okay, so Ethereum fees have two components: the priority fee and the base fee. The priority fee is it's going to augment the staking rewards. The base fee is burned. Okay, so that's going to reduce the money supply. It's like negative seniorage. And so in the model, I'm going to have an endogenous fee rate that's determined, and the cash flows are sort of flowing according to protocol. The Ethereum has this again, we heard that, and most people know it's measuring its block space usage in terms of gas, and so what I'm going to do in this model, it's not just a model about money, but it's also block space. Okay, so block space or gas, and so the view is that there's a very simplified view. A blockchain is producing two types of services, two types of goods. And that's going to give you this sort of two good model. Okay, we have the block space and money. Of course, there's a relation between them, but in some sense they're separate. They're separate goods, and so the model is going to have that. And then there is the L2 sector. Okay, I call it a sector here. Again, we've heard a lot about it this morning. So the view here is that there's a whole bunch of L2 firms, and they're competing, and they're producing their own block space. So the model is going to have L1 block space, L2 block space. These are imperfect substitutes. Yes, it's slightly different, and the L2s, they will use some of the input. Again, we've seen this morning from the L1 to produce this block space. Okay, so this is the big picture. The model now, compared to what the first simple model we've seen, everything that's in bold is added for Ethereum. Okay, there's still some money that's used or staked. There's agents that they get utility, but not just of money now, but also of a block space. There's three types of gas. Yeah.
So are you thinking of any part of the block is equally valuable?
Well, they can be. The model is going to value. You can value all the pieces.
So part of what I'm getting at is like when I think of the priority fee and the base fee, one way I kind of think of it conceptually is a bit like there's preferences across blocks. Like I'm impatient. I want to get on this block instead of the next one. And then there is within this block. I actually care where I end up because, for instance, I'm doing an arbitrage trade, and so what the hell is the point of me being at the bottom of the block? Right? That's in some sense ideally where the priority fees value is supposed to. I think in the idealized vision, right? It's like the reason the people are paying the priority fee is just within that block, they are competing for the better real estate. And so part of what I'm wondering is like the framework you're going to be showing us, does it incorporate that sort of difference in preferences where it's not just like we're all interested in having real estate, but like there's some houses that are really nice or something like that.
Yeah. So the of course it is an aggregate model. It's a macro model. So there's one fee rate that captures sort of the average cost, and so it's just.
Think at the preference side, like when you talk about these goods, like my preferences over these goods. Is there a sense in which, for instance, are the goods, is it like homogeneous or is there some like sort of heterogeneity within the good?
Yeah, the good's the same. The income is split. So there's one good block space, and there's no differentiation. Okay. The income, however, is split because that I want to have the cash flows, and that's split in a. You'll see it in a second. It's very simple. It's just a share. A share of it is coming from priority fees, and the rest is burned.
But so like, is the priority fee endogenous in the model?
The overall fee rate is endogenous. The split's exogenous. Again, I think that's given it's a macro model, it's reasonable. I used to have it that split used to be stochastic, and that sort of estimated it and tried to sort of take that more seriously. It doesn't really matter for the things that I'm doing, just because the type of it actually doesn't seem to be moving that much over time, and if it moves, it's just. Relative to other things moving, it's not essential. That of course it depends also on what you're looking at.
Yeah, I guess part of it is like, for instance, like if it was all payments, like if Ethereum was all payments right now, I would imagine the priority fee would be pretty low.
That's right.
Whereas if it's like all arbitrage DEX trading, now I'd expect that to be very high.
Yeah.
So I don't know exactly. I'm sure what you're saying is like, that's how the data looks, but I guess what I'm saying is there's like there might be something endogenous behind that. Like,
No, I agree. Absolutely. Again, it's always the same excuse. If you have a macro model, you can just say this is too micro. I look at the big flows, but no, obviously these things are important. There's no doubt.
Maybe like if all the trading shift to L2, so in Ethereum priority.
I think there's a whole other conversation when you bring in the L2s, but okay, that's
Okay, so let's go back. There's three types of block space here. Okay, that's sort of a level of differentiation they have. There's the L1 block space, the L2, and the blob data. Again, we've talked about this morning. The way I think about the L2, so what an L2 does here, L2 uses as input the L1 block space and the blob, and then it produces its own block space, and they have decreasing returns to scale, so they're going to make some profit. The money supply is moving in the way the fee policies are specified, so that's going to be included. In this model now, there's more prices. It's not just the price of the token, but it's the gas. So the gas prices or fee rates, they're all separately determined. And it's a stochastic model, and so there's three types of shocks that are driving this economy. There's sort of what I call adoption productivity shock. It sort of moves the main utility up or down. That's a non-stationary process. There's a discount factor shock. Think of that as that's financial markets, interest rates, risk aversion of investors, and then there's the gas demand shock. Okay, these are the equations. I'll show you just one equation. Okay, one choice you need to make. You need the utility function. Okay, the money and utility. It's always a bit tricky. So I'm picking something that's very simple. Okay, so it's just a log function, and then you just have these utility value shares that determine what the relative weights are on the money part and the gas part. Okay. Now that even within this type of model, you can obviously make it more richer and makes sense to have it richer. But for now, haven't done that. Okay, these are the shocks. Okay, this is just Ethereum. Okay, so just that to close the model, the staking policy is just following what's in the Ethereum protocol. Ethereum has these square root, these inverse square root function. So it just tells how much is our stakers compensated. The K is just a number that's in the protocol. Okay, so you can look it up, and then the amount is moving with the inverse of the square root of the aggregate D, which is the sum of all the amounts deposited. And here you see the picture of it. If staking is low, then the returns are high, and that makes sense because you don't want to be too low. And then when it gets higher, that compensation goes down. Okay, so in how much time do you sort of lost track of timing here?
Like 10 minutes.
Only 10 minutes for the whole thing? All right. Okay, good. So I still want to talk about price. Now this is these type of models, they're also used for asset pricing. So you can talk about pricing. And so one question, I mean, people discuss a lot. What gives the token value? So in this model, there's a number of sources that gives the token value and affects its value. Okay, there's the store of value that comes through discounting. There is the sort of convenience or medium of exchange. That's the money utility, and then there's the fee and the staking. And so if you look at the way this works in the model, there is from the user side, the price is the pricing equation is this. Okay, so the price is a discounted present discounted value of the sort of utility cash flows, and this is it decreases in money because if more money is used, the marginal utility is driven down. Okay, so that's sort of the way it works. Now, the question is, if you look at this equation, is there any way this equation could be used outside the model? Okay, if in the model this is well defined, you can solve it, but take it out the model as a standalone, as a basis for maybe fundamental valuation of these tokens. Of course, if you want to use this, or if anybody wants to use this, you have to buy in on the functional forms. That's some make a step. The key is this A, the sort of level of productivity. That's in the model. It's an arbitrary number. So it's very hard to sort of figure out what that should be. However, in the model, A shows up in other parts. A is also in the first order condition for gas. Okay? So gas also benefits from that, and so you can substitute it out, and then you have something like the fee payments from the users that substitute it, and then you would get an equation with preference parameters and fees. Okay, that's something you could measure. Now fees are also, of course, they show up when you look at the other pricing equation from the staker side. Okay, so if you take the staker's pricing equation and you iterate it forward, the price of the token is just the present discounted value of the cash flows, okay? and these are the rewards, and these are the priority fees from the two block space types. So this is, of course, something you could use for fundamental valuation, but there's an issue here, and is if you the issue is that the price shows up on the other side as well. Okay, so you could use this for fundamental valuation, but what you're doing is you're saying something about the current fundamental price as a function of what you think the future price is going to be. Okay, so that's this sort of circular logic. So that's somewhat of a problem. Now, if you look at the equation more closely, it's a problem for the staking yield. Okay, because that's just distributed by the protocol. It's less of a problem for the fee payments, because here the price, you could think of it as it's really reflecting the payments in dollars. Okay, so with the price it becomes dollar payments. It's sort of the willingness to pay by end users. Okay, so that's more like a fundamental quantity. So you could use this equation with this part, but then you still have to deal with the yield, and this is, of course, this is now the larger part of the payment. Now again, you could use the model to get a restriction on this, and so you could go if you go to the steady state in the model, then the equation looks like this. So that now it's just in steady state the value is just equal to all the fees. Okay, so these are the fees from the L1 block space and from the blobs. Yeah? So why is it like this? Why is it simplified to this? The steady state with this monetary issuance rule, there's only one steady state. It's a constant money. Money growth in the long run is zero with this function. It cannot be anything else. And so what that means in the long run, these rewards, they will be paid out of the burn. Okay, and money stays constant. And so that's why it all ends up to the stakers. Okay. And so that, this equation now, of course, you can, that we can work with. And now it maybe, the price picture I showed you, maybe it's not so surprising. It's going down because the fees have been going down and the Ds have been going up. Okay? So is there a way around this equation? Yeah, this equation looks like it's constraining the value of the token. Okay, and so I guess the ways around it, I can see two ways around it. One is changing the issuance curve to make it inflationary, and then some of the rewards are paid with inflation. Of course, that's probably not what people are looking for, because then it's going to drive down the price through money here. The other possibility, and we heard some of that in the last talk this morning, is to have staking. Staking would need to have additional utility produced. It's not just of course, I'm ignoring also the cost here for now. But if you can, have restaking as an additional source of income, that could help it. But of course, that also has its risks. Okay. Okay. So these are a few, just some comments on the pricing. I think it's obviously still a very much open questions of how tokens like this should be valued. But maybe general equilibrium models could be useful too, because you can get additional connections. Yeah?
So in that last equation, preferences drop out, right?
Yeah. Because this is the key. So this is no longer, absolutely right. This holds for any model as long as there's not.
So it seems like it just follows some no arbitrage.
Yeah.
Like deriving Black-Scholes,
Yeah, and of course, what's key here is you need the type of monetary rule that we've seen, and you need to see the steady state, what it looks like. But then, it falls, that's it. Yeah, absolutely. Yeah?
So as you explained, ETH sort of pays out its fees to users in two ways. One thing looks like a dividend, staking reward, and one thing looks like a buyback.
Yes.
Does that have anything to say about the value of ETH or about the functioning of the ETH economy? Like, does it matter that some of it is buyback and some of it is staking yield, or does it make any difference to change that? If we're all yield and all buyback, or vice versa?
Well, it's different because it goes to different users. I mean, so you see the priority fees, they only go to stakers, while the buyback, they go to everybody. So that's more broadly spread. So it has a different impact, but
I don't see it in these equations.
Well, here it doesn't matter anymore in the long run, because first the key in this equation, okay, the users are not here anymore. You divide by D. It's just the staked amount. So it doesn't matter what the overall money supply is, because it's just all the fees in the long run, they go to stakers, and then the value is just whatever the total fee income is per unit of stake. Okay, and the rest of the money supply here is actually it doesn't matter anymore.
Maybe one follow-up.
Yeah.
In the macroeconomy, we think that the rate of inflation of the money supply may have implications for the functioning of the economy, like the nominal rigidities and things like that. In the Ethereum economy, does that sort of thing matter?
Yes, there is, and let me get to the next point. Okay, so then I have 5 minutes or.
Let's say 5 minutes.
All right. So the policy question, which I guess the price is always fun. So, but the policy question is now the staking yield. Okay, and so that's where this comes in. So this model you can solve. You can solve the steady state. You can solve it. A bunch of algebra. The key is this: the staking ratio, the staking share. Okay. In this model, it only depends on. These are just the preference parameters. It doesn't depend on. It doesn't depend on the monetary issuance curve anymore. Okay, there's no K, that doesn't show up here anymore. There's no squares. Okay, so the functional form it drops out, And that's sort of a property here, which is related to what we just discussed. In this model, in the long run, and the monetary policy, the issuance doesn't matter for long-run staking share. Okay, whatever you do, it's just going to be neutral. Now that's a function of the, it obviously depends on the elements of the model and the assumptions made, but it's much more general than that. Yeah. Mm-hmm.
So like this is a representative agent model, right?
Yeah. Yeah.
So like I think one of the things, at least from my understanding, that the Ethereum Foundation sometimes talks about is like the solo stakers versus, for instance, staking pools and so on.
Yes.
So sometimes they're considered, like the micro in some sense matters there, right? So is this going to still hold, for instance, if you have like different preferences for different agents and like there's heterogeneity of that kind?
Yeah, so what you need, of course, for this to matter, you need in this model, the models I've shown you today, the staking, is, we just assume it's useful, but it's not modeled how it is useful and how it affects the economy. I have another model where if you want to make the true policy decision, you need to decide how staking creates value. Here it doesn't. It's just a cost, and there then it would matter depending depending on how you make what part of staking you think is contributed to the security of the network and how you model that. So, but here that's not included. It's just a cost. Okay. I guess the key result here is that it's a much more general result. With Ethereum's issuance curve that depends on the level, the only stationary long run is one where money doesn't grow. Okay, so that's why we don't have different levels of inflation anymore, and because of that, tweaking around tweaking this issuance curve is not going to have any real impact. So what you need to do, and what I think would be a better way to do, and if thinking about going to another issuance curve, it's having it as a function of the ratio, not the level of money. That would make it that depending on the policy, you have different growth rates, and there's different distortions. So the model is the distortion we talked about at the beginning. That depends on the monetary growth rate. The more money grows, the more there's distortion, the more it reduces the usage. And so that I think it makes sense. It's also what some recent, I think there's a Solana proposal recently for another issuance curve. They also use something that depends on the staking, the share, the ratio, not the amount. Yeah.
How would you extend the model to take into account competition from other blockchains like the Solanas of the world? Because the price of gas can't go to infinity because people just use other blockchains.
Yeah, that's a great question. This is probably what I'm doing next. I mean, it's a bit like, we have single economies. These are like closed economies. At some point, we want to have open economies where economies interact. I think it's, that's definitely has to happen. I mean, when I started this, it didn't look like we need this. So 2 years ago, there wasn't that much competition. It looked like there's sort of the network effect will be strong enough, but maybe that's not a good view anymore. So let me just summarize what else you can do. I'm not going to show you any more. So the model, you can estimate this model. Okay, so you use data on fees, on prices. Of course, the problem is data here is not very long. Okay, so extrapolating for the long run, that's challenging, or to say the best. And then because I've compared different issuance curves that have been proposed by, one of them is proposed by the Ethereum Foundation. Again, all the issuance curves I look at are on the ratio, not on the level, because on the level in this model, this has no impact. Okay, this doesn't anything. And then you could do some stress tests. So assume, I guess some you can run the model. The staking, the long run is about 26%. You can stress test this model. You can do this in many ways. Things changing, that staking goes up a lot, and then with the different sort of issuance curves that are proposed, you can see what happens. And some of these curves, they would work pretty well in limiting the increase in staking with no sort of obvious strong sort of negative side effects. Okay, so.
Thank you.
Okay.